All right, so today's lesson we're going to look at planar graphs and Euler's formula. Euler was just a mathematician who came up with a theory. So first of all, let's have a look at planar graphs. So a planar graph is a graph that can be drawn in such a way that no two edges meet or have common points, except at the vertices. So if you have a look over here in this example, these are examples of planar graphs. So what you can see, the lines are never crossing each other. What's an example of a non-planar would be if I had something like this, so, or like that. So see, when the lines cross each other but there's no vertex, that's not planar. So planar is when they're all nice and not crossing each other. All right, so, and we found that, so that's it. So some graphs can be redrawn to not be, so some graphs that aren't planar can be redrawn to be planar. So you move one of the edges away, and we'll look at that in a minute. Now, Euler, he confirmed this theory, and Euler's formula can be used whether the graphs are planar or not. So that's important because sometime later on we will see rules that can only be used if it is planar, but it doesn't matter. So here's Euler's formula. So Euler's formula talks about vertices, which we know, they're the points on our graph. It talks about it uses edges, so edges are the lines joining those points. And now this last one that we're going to look at is we're talking about faces. So faces in a graph include the areas that are created by the graph. So I'll draw an example for you. So say I'm just drawing a network up here. Just making that up. All right. So if I'm counting the faces, what you're counting the spaces that it's made. So here's, this would be one face. This is a face. This is called a face. And actually always the area that the network is on is also a face. So we've got 1, 2. This one that I've drawn up has three faces. Okay. So if we look over here on the diagram down here, they've counted the faces, so they've colored them in. So we've got 1, 2, 3, and they've called the outside face 4. All right, so Euler's formula found that if you do count the number of vertices, you minus the edges, and then plus the faces, you'll always find you get an answer of 2. So if I go up here and I'll test out this theory up here. So if I look, the vertices, I've got a 3. So 1, 2, 3. The edges, if you look, I've got 1, 2, 3. I've got 4 edges. And I said faces, I had 3. So if I do his formula, I would be 3 minus 4 plus 3. Does that equal 2? It does, doesn't it? Yeah, because this would be -1 plus 3 is 2. So it does work. All right, so that is Euler's formula, which we can use to maybe solve something. So just recapping down there what I said about the faces. So the faces of a planar graph, areas that are the finite or infinite. So what that means is this out here is the finite, like the infinite area. That's what they mean by that. So you've got to count the outside area as well as the ones that are enclosed. There is always a face that surrounds a graph, yeah? And the graph must be drawn with no crossing edges. So if you're counting the faces, you've got to make sure you don't have, if you're going to, you don't have crossing edges. Otherwise, that's still just one face. All right, so converting graphs to planar. So before you saw, I said you might have a graph that isn't planar, and here, down here, we can see it. See how they're crossing there? So that isn't planar. because they're not crossing. The only places they're supposed to cross is at the vertex. So they've redrawn this graph here, and they've made it by rearranging it. So they move out one that was getting crossed, and they've changed it around, and it can be redrawn like that. So there's a couple more examples. So there, when it's crossed, and so on. So these ones are a little bit more complicated up here, but let's go do one down here on our example. So it says redraw the graph shown opposite in planar form. So at the moment, it's not, because it's crossing there. So we don't want it to cross there. So what we want to do is I'm going to remove this edge here. I'm going to make it different. So if I go and draw this graph, so I still got A going down to D, and still going up to B, and it's still going down to C. But what I'm going to do now is connect A and C without crossing. So I might go like that. So can you see I've redrawn it without them crossing? So now this is planar, and this is non-planar. So so we can look at that. So if we wanted to test Euler's formula, let's just have a go. So we know it was V minus E plus F should equal 2. So I'm going to say, how many vertices has this one got, boys? Vertices are the points. So someone tell me. Sorry. 4, good. Let's count the edges. Often easy to sort of highlight them. So 1, 2, 3, 4. Okay, so we have the edges is 4. And then how many faces have we got? If we count the faces, here's face 1. And remember, the area outside is also counted, so face 2. So I've got 2 faces. So if I put these numbers under here, I'd have 4 minus 4 plus 2. Does that equal 2? Yes, it does, doesn't it? So we've proved Euler's formula there. So here's a couple more examples of how we can get asked using Euler's formula. So it says consider the connected planar graph. So remember, if we can't remember what connected is, remember connected means I can get to every vertex in the network without taking my pen off. So you can see I don't have to lift it off. So it's all connected, that one. And the planar graph, we can see that no edges are crossing each other except at the vertices, so that makes it a planar. All right, so going back to, let's write down the number of vertices, the number of edges, and the number of faces. So let's have a look over here. So vertices are 1, 2, 3, 4. If we go to the edges, we've got 1, 2, 3, 4, 5, 6. 6 edges. And if I count the faces, I've got face, there's 1, face 2, face 3, and face 4. So I've got 4 faces there. And then it says here, verify Euler's formula. So remember, we're going to write it down. V minus E plus F equals 2. So 4 minus 6 plus 4. And yes, that does equal 2. All right. So a connected planar graph has 4 vertices and 5 edges. Find the number of faces. So here's where we know V equals 4 and E equals 5. Now they've told me it's a connected planar graph, so I can use Euler's formula, and they want me to know faces is the question. So if I wrote out Euler's formula, so V minus E plus F equals 2, but I know V is 4, and I know E is 5, and plus F equals 2. So I'm just going to do it like a normal equation. So 4 minus 5 would be minus 1 plus F equals 2. So if you move this 1 over an equal sign, it will do the opposite. So F pretty much equals 2 plus 1. So F equals 3. So find the number of faces. So faces, there was 3. Okay, so that's where you could use Euler's formula.